Hello everyone, it's been long, so I just wanted to touch base with you. I want to talk about plotting of functions, just to give you some hints on how you can plot functions. Of course, there are many things that you need to have or to know for you to plot a certain function. But for the simplest function, such as the linear function and the quadratic function, you don't need a lot of things to plot. You don't need a lot of data points to plot. Now, for these functions, the first thing you need is the domain, then you need the range. Where is the function defined? You need to have a certain domain, okay, or a certain interval where this function is defined. And of course, you need to have a range of values of the outputs, okay? So then what else do you need? You need the y-intercept. What else do you need? You need the x-intercept, okay? For graphs that are linear, they are simple to plot. But for the graphs that are not, linear, those graphs that are not linear, you further need certain things such as a turning point, okay, and so on and so forth. And some graphs, of course, which are not linear, you need things like the asymptotes. You have to know the asymptotes. So now let me just give you an example of the linear plot, okay? So here you have a line y is equal to mx plus c, okay? This is a linear function, okay, which I presented to you in coordinate geometry, the introduction, okay? So this part here, this is where the line cuts the y-axis, and this point is called the y-intercept, okay? This is the y-intercept, and where the curve cuts the x-axis, it's called the x-intercept, okay? This is the x-intercept for this linear equation. Then for this equation, which is like a wave equation, we have the x-intercepts here, okay? This is where it cuts the x-axis, and then we have the y-intercept here, okay? Yeah, we have several x-intercepts and we have one y-intercept. So we need to have these details for us to plot the graph. Let me just give you quickly one example. Plot the graph of y is equal to x plus 1. Notice this is in the form y is equal to mx plus c. Okay, this is a linear equation. So we only need the y-intercept and the x-intercept. So at the y-intercept, the value of x is 0. Then at the x-intercept, the y of y is 0, okay? Because that's where the curve is cutting the x-axis. So y is 0, here x is 0, okay? So for this example, y is equal to x plus 1, okay? Which is y is equal to f of x. So the domain, this function is defined from R to R, okay? This is a set of real numbers, because any number you put here, this function is defined. Put 0.1. 0.1 plus 1 is 1.1. Put -1. -1 plus this, it's 0, okay? Any number you put in place of x, this function will be defined. So the domain is x such that x is a real number, okay, defined from minus real to real, okay, to positive real numbers. So this is just a set of real numbers. Then the range also, for every x, which is the input you put, you get the output, which is the real number, okay? So if we put any real number here, we get the real number as the output. So the range also is such that x is a real number, such that y is equal to f of x, this will be a real number. Okay, this is the range of values. These are the y values, then these are the x values. So now for the y-intercept, at the y-intercept, x is equal to 0. Okay, at the y-intercept, x is equal to 0. Intercept. At the y-intercept, x is equal to 0. Okay, this is intercept. X is equal to 0. So we put 0 in place of x. So y is equal to 0 plus 1. So the y-intercept is 1. Then at the x-intercept, this is sept. Okay. At the x-intercept, y is 0. So you put 0 in place of y. So you have 0 is equal to x plus 1. So x is equal to negative 1. So this is the Cartesian coordinate, x or y. What is the x-intercept? The x-intercept is negative 1, okay, because x is equal to minus 1 when y is equal to 0. So the x-intercept is minus 1. And what is the y-intercept? Is 1. So this curve passes through minus 1, 0 and 1, 0. So we just join these 2 points with a straight line. So this is the graph y is equal to x plus 1. Okay, this is y is equal to x plus 1. Similarly, we have another linear function. Okay, y is equal to 2x plus 4. So the domain, it's the same as the previous one. The range is also the same as the previous one because this is a linear function. The domain is the same and the range is the same. So for the y-intercept, x is equal to 0 because that's where the curve cuts the y-axis. So at that point, x is 0. So we put 0 here where x is. So y is equal to 2 times 0 plus 4. So y is equal to 4. So the y-intercept is y is equal to 4. Then for the x-intercept, y is 0. So we put 0 here. Okay, so 0 is equal to 2x plus 4. Then we make x the subject to the formula. So 2x is equal to minus 4. X is equal to minus 2. So this curve cuts the x-axis at minus 2. So minus 2 and 4. So we join these 2 points with a straight line. So this is the line. Y is equal to 2x plus 4. Okay. These are linear graphs, this one and the previous one. Okay. All right. Now let me do one which is slightly different. So y is equal to x squared. Okay. For the domain, you have x such that x is a member of real numbers. Okay. Every real number you put here, negative or positive, this function is defined. But for the range, okay, range is such that x squared is equal to y, such that x is equal to square root of y, such that f inverse of x is square root of x. Okay. If it's easier to do this for you to find the range. So range f is such that x is a member of R and x is greater than or equal to 0 because any number in the square root is greater than or equal to 0. Okay. Oh, you don't need to do this if you think very fast. You know, just know that any number squared is greater than or equal to 0. Negative 1 squared is greater than or equal to 0. So squared itself is 0. Okay. Any output you will get from here, it will be greater than or equal to 0. So the range is greater than or equal to 0. So now for the y-intercept, x is equal to 0. So you put 0. Okay, so y is equal to 0. So the curve cuts the y-axis at y is equal to 0. And also for the x-intercept, y is equal to 0. Y is equal to 0. So x is equal to square root of 0, okay, which is 0. X is equal to 0. So it also cuts the x-axis at 0, okay. So what are the intercepts? 0, 0, okay. So this is the origin 0. So the curve passes through the origin, okay, because the intercept of y is at 0 and of x is at 0. Okay, and then you need to know the turning point, but this is this definition will only work for a quadratic equation, a quadratic function, but this one is a special case. So here actually you need to know the derivatives, and yeah, of course, when you know that at the maximum point and the minimum point, dy over dx is equal to 0. Okay, so y prime is equal to 0. So y prime of x is 2x, and if y prime is equal to 0, so 2x is equal to 0, x is equal to 0. The time point will be at 0, but that's a different concept. So this curve passes through 0 because that's where the y-intercept is, and also the x-intercept is at the same. So there it is. Yeah. Yes. We will continue with more plottings. Okay. You can ask a question if you have. All right. Thank you.